Hello my dear students. So today we will be discussing electrochemistry. So we already started discussing about this electrochemistry in the last session itself, and we have seen about electrochemical cells also, right? So now in this session we will be discussing about the conductance and conductance of electrolytic solutions. Okay, so this is the topic we are going to focus here. Okay, so we will be studying about conductance, resistance, conductivity, resistivity and their relations, and after that we will be looking into few questions related to this concept, and the next we will be discussing about molar conductance. Okay, so let us start our session here. So this will be very useful session and will be again very important topic also. Okay, so now before going to start our session, so I just wanted to tell you that about our new batches that we are going to launch for NEET 2026, that is long term program here. Okay, so these batches are starting from 1st July 2026. Okay, so 2025. So here they mentioned it as 2026, it is 2025. Okay, and so in these batches we will be guiding you through online as well as offline mode. The lectures will be provided offline as well as online mode, and these lectures are also in the available in the app, that is what NEET World app. Okay, so where you can access these live lectures as well as recorded of the same live lectures. Okay, and you can also get the lecture notes, okay, after the class. Okay, so that will be helpful for you also, and you can also make the notes from it. Okay, now we will be completing a full syllabus, okay, within 6 months, and the next we will be also providing well crafted study material for offline students. Okay, and for online we will be either sending them to the courier, or you can get the soft copy also along with that. Okay, so here we will be also providing one-on-one mentorship both in online as well as offline mode, and the cost of this batch is 3333, which is very affordable for everyone, right? So this is the cost for per month. Okay, so I think you got about this everything about this new batch, and if you wanted to know more about this particular batch, you can just contact to the below provided mobile number which is scrolling here in the down. Okay, and the next we are also having a new batch for this JEE 2026 long term. Okay, so it is also having same fees for mains 3333, but for advance it is 4166 rupees. Okay, so this is about JEE mains and advanced batch, and if you are a non-local guy who is also looking for hostel, yes, hostel facility is also available for both girls and boys separately. Okay, yeah, so this is about the new batches which are commencing from 1st July. Okay, so let us start our session here. See what exactly we have studied. So we have studied about electrochemical cells in the last class, and we need to study about this electrolysis, and before going to that, let us understand what are these conductors. Okay, so conductors are all those substances which allows passage of electricity through it. Okay, so these can be of different types. They can be in the solid form, liquid form, like this now. So now these are generally conductors are of two types here we are taking. So one is metallic conductors, or simply we can say electronic conductors we can say. Okay, metallic conductors, the other name for the same compound same is electronic conductors, and one more we have is electrolytic conductors. Okay, so these are the two things we are going to learn. So first, what we can say, substances those which allows a passage of electricity through it. Okay, so these are of two types. One is metallic conductors, it is also considered as electronic conductors. Okay, so now what are the properties of these particular conductors we have? See, conductance in metals is due to mobility of electrons. See, in the metals, electrons are freely surrounded around the nucleus of the central atom, right? Nucleus of that atom, right? So we can call it as electron C model. Okay, so due to the mobility of these free electrons around this nucleus in an atom, so the electricity is passes, right? So that is the reason the free electrons here, mobility of electrons is responsible for conductance in the metals. Okay, so metals may conduct electricity in solid, molten state or even in dissolved state also. Okay, so now what happens with the rise in temperature, the conductance of these metallic conductors decreases. So if temperature increases, this is the important point you need to remember. If temperature rises or increases, conductivity let us indicate with G symbol G. Okay, so you can write if temperature increases, conductance decreases in case of metallic conductors, in case of metallic conductors. So why it is decreases? Because due to the increase in temperature, what happens? Vibrations takes place in the kernels of this metal. So what happens? The kernels will keep on vibrating here. So due to this, what happens? The conductance decreases as we increase temperature. Due to increase in vibration, their conductance decreases. This is what you can remember. Okay. The next here, what about electrolytic conductance? So here electrolytic conductance means what? This is the conductance in electrolytes. Okay. So now conductance is here. What is the reason behind the conductance in the electrolytes? It is because of movement of ions. So there it is movement of electrons in metallic conductors. Here it is movement of free ions. For example, I am taking NaCl solution. So when I am saying NaCl solution, so let us say in the aqueous medium, what we have? NaCl ions are there. In the water we have Na plus Cl minus ions. So due to the mobility or due to the free movement of these ions, okay, so what happens? The conductance or the electricity flows through it, or these ions will carry the electricity through that particular solution. Okay, so what happens? The movement of ions, conductance is due to movement of ions to oppositely charged electrodes, right? Okay, so here what happens again? So transfer of matter takes place. So it means here we have both oppositely charged electrodes we have. This is positive, this is negative we have, and here let us say Na plus sodium chloride solution we have. So what happens now? These Na plus ions, the cations will all move towards this negatively charged electrode, and this all anions will move towards positively charged electrode. So what happening? So here we are seeing transfer of matter. Cl minus is a matter that is transferring to positive charge, Na plus ion that is transferring to negative charge. Like this you should understood. Okay. Then next, so transfer of matter takes place, you can say. Hence decomposition also takes place. See, electrolytes which are almost completely ionized are called strong electrolytes. See, we have also studied about electrolytes. So electrolytes are two types I told you. One is strong electrolyte, another one is weak electrolyte. How can we decide which is strong, which is weak? So this is based on the depending upon degree of dissociation. So if an electrolyte dissociates completely, if a substance dissociates completely, we can say it is a strong electrolyte. Examples are this NaCl and strong acids like HCl, okay, H2SO4, like this. And what about weak electrolytes? These are partially dissociates. For example, weak acids. Weak acids means like acetic acid we have, and weak bases, ammonium hydroxide, like this. These are weak electrolytes. Okay. So now electrolytes which are almost completely dissociates can be considered as strong electrolytes. Here we have mentioned few. Okay. So electrolytes which do not completely ionize are called weak electrolytes. Example, see, carbonic acid, acetic acid is given, like H3BO3, boric acid is given. So these are few examples here we have. Then next, see, what are the factors affecting this electrical conductivity of electrolytic solution? See, we have studied about metallic conductors as well as electrolytic conductors we are studying now. So now let us little more look into this electrolytic conductance, because we need to study about solutions like chemicals, right? Yeah. So those solution, electrolytic solutions, how do they show the electrical conductivity, what is the resistance, all these things we need to look here. So that's why let us look what are the factors affecting this conductance for electrolytes. Okay. See, inter-ionic force of attraction. See, if both oppositely charged ions are having more inter-ionic attractive forces, now what happens? Their mobility decreases. Now the ions mobility decreases because the oppositely charged two ions, inter-ionic force of attractions are more, means their conductivity is less, because the movement of freeness of that particular ions will be decreases due to intermolecular force of attractions between them. So what I can say, inter-ionic forces attraction increases its conductance decreases. See, larger the solute-solute interactions, lower the extent of dissociation and lower will be its conductance or conductivity. Hope it is clear. Next, solvation of ions. So solvation of ions means, for example, if you are placing one ion in the water, so what happens? For example, let us take one cation. See, I am taking here potassium cation, okay, then next sodium cation and potassium cation, two cations I have taken here. So if you consider these two things, see, place these two cations in the aqueous medium, it means in the water. So what happens? So water molecules having this electron density, that will surround these both positive charges, right, these both positive charges. So when they surround these both positive charges, what happens? This size, now we should say this size of this ion as hydrated ion size, okay. Now here we are just looking as a cations, but when we place in the aqueous medium, the water molecules will surround this Na plus and K plus ions. Therefore, their size, what happens? The hydrated ion size increases. See, if you look normal ions, the size of K plus is greater than Na plus, but when we consider its hydrated ion size, since it has small size cation, now it will be attract more number of water molecules around itself. Therefore, its hydrated size or like hydrated ion size will be larger for sodium when we compare with the potassium. Now hydrated ion size we need to compare when we are discussing about conductance in the aqueous medium. So therefore, hydrated ion size is larger for sodium ion, therefore it will be having lower conductivity, okay. So whenever they are asking about what is the effect of solvent, okay, so in this case you need to look for the hydrated ion size. Larger the hydrated ion size, so lower will be the mobility, so lower will be the conductance, because more mobility means more conductance. Since larger ion means it will be having lower mobility, less mobility, so lesser conductance. That is what you need to understand from the effect of solvation or solvation of ions. Then next, viscosity of solvent means larger the solvent interaction, larger will be the viscosity, okay, lower is the conductance. See, viscosity is nothing but mobility to hindrance to the mobility only, na, right. So if more viscous, lower mobility, so lower is the conductance. That is what you need to understand. Next, what about concentration? So concentration here, so upon increasing concentration, see, when we have some, for example, I have 1 molar solution, so upon increasing, upon adding water to it, it means it will undergo dilution, right. So here we have actually, there are two different types of effects, we will study about that, okay. So now I will be telling you one general explanation for concentration. Again we need to have a special discussion on concentration anyways, okay. So upon dilution, degree of dissociation increases, therefore conductance increases, its conductivity decreases. I will tell you after some time what exactly conductance, conductivity, then we will come back to this later. The next, what about temperature? So electrolytic conductance increases with a rise in temperature. Again this point is important, because for metallic conductance, for metallic conductors, what we have seen, upon increasing temperature, vibrations in kernel also in kernels of that metal increases, therefore conductance for that metals decreases. Increase in temperature decreases conductance in case of metallic conductors. But in case of electrolytic conductors, so with rise in temperature, ionization of that particular substance takes place, therefore number of ions increases or ionic mobility increases, you can say. So they can move freely with increase in temperature, with rise in temperature, their kinetic energy increases, you can consider other ways. So therefore what happens to its conductance? Yes, since mobility increases, its conductance value also increases. Hope it is also clear, right? So now if it is clear, just click on the like button first. Yes. So let us move further. So now tell me, answer for this question, strong electrolytes are those which are, what are the options which are correct for this? See, dissolve readily in water or conduct electricity, dissociates into ions even at high concentration, dissociates into ion at high dilution. Tell me. So what is your answer based on your understanding? Dissociates, dissolves readily in water, yeah, okay, and conduct electricity, yes, they will conduct electricity. Next, dissociate into ions even at high concentration, yes, they will dissociate into ions, no, Yes, so you can go with option number 3 also. Okay, so now let us look into the next one. What exactly conductance here? So conductance and conductivity. So conductance means it is a property of conductors. So property of conductors, what here exactly? So property of conductors, metallic as well as both electrolytic. Okay, so which facilitate the flow of electricity through it. So what we have studied, conductance means it is a like flow of electricity through that particular substance is what its conductance. Okay, so now conductance is inverse of resistance. Okay, so I have taken it as G represents conductance, that is reciprocal of resistance or inverse of resistance we have taken here. Now we need to understand what exactly resistance also. Okay, so see what are the factors here which on this conductance depending. So magnitude of conductance depends mainly on, so how much the conductance value we have, it depends upon number of ions. More the number of ions, more is the conductance, like this. And magnitude of charge on each ion, the next ionic mobility, so distance travelled by ion per second under potential gradient of 1 volt per centimeter. Okay, so these are the 3 factors we have. One is number of ions, then next magnitude of charge on that ion, and the next ionic mobility. More is a mobility, more is its conductance, right? Yeah. So now in order to understand resistance, let us study about Ohm's law. So what we have Ohm's law, the current carried by a conductor may be electrolytic or electronic, both. Okay, so electrolytic solution is directly proportional to the potential difference. Okay, so here I equals directly proportional to I, directly proportional to V, we can say potential difference. So between the two ends of the conductor. So from this we can write V equals to IR or RI. So here R is just a proportionality constant, just they removed proportionality and they replaced it with R. So that R they are saying it as what? Resistance. So resistance is taken by V by I, like this. Okay, so we need to study about this. See, this thing you have studied in physics. Okay, so we need to study about this resistance here. So what exactly resistance? So it is a measure of opposition to the flow of current in an electrical circuit. Okay, so now that is something like hindrance to the flow of current, I can say. What is resistance? It is a hindrance or opposition to the flow of current in an electrolytic solution if you are talking about solution, or circuit if you are talking about electronic or metallic conductors. Okay, so now resistance, I am writing resistance directly proportional to length. For example, we are talking about wire, let us say. So wire will be having some length now, yeah, so that directly proportional to length and inversely proportional to its cross sectional area, like this. So from these two things I can say resistance is directly proportional to L and inversely proportional to the cross sectional area, okay, of that particular substance, material, you can say. Now I am removing this proportionality and I am replacing it with something called rho. Rho is called as resistivity, whereas R is called as resistance. So this is what? Resistance, and this is what? Resistivity. L by A means L is the length, A is area, that material, area, cross sectional area of that particular material you are taking. Okay, so now, so what is the units for resistance? So for this we have ohm. Okay, you can represent like this, or you can write simply ohm like this. And resistivity, what is the units of resistivity we need to get? So for that, so here L by A we have written now. So L means let us say centimeter, so area will be having centimeter square. So from this L by A means what will be having? So centimeter inverse in the bracket, in the denominator. Centimeter will be in the denominator, like this. L by A we have now. So here ohm. Okay, so here we will be having centimeter. So just send this side. So these are the units for resistivity. So what is the units for resistivity? Ohm into centimeter. Hope this is also clear. These units are very, very important. They will ask you in the exam also. So now we need to talk about more about conductance here. So what we know, conductance is inverse of this resistance. So wherever we have rho R, I am writing it as G. So why I am writing? So G conductance is nothing but the reciprocal of resistance. So replace that value over there. So 1 by G equals to, from here I am writing, let us say this is first equation. So rho into L by A I am writing. Okay. So now inverse of resistivity can be considered as conductivity, 1 by K. Okay. So here I am writing 1 by R, 1 by G equals to rho into L by A I am writing now. So here I can write this as 1 by G equals to rho into L by A we have now. So this L by A, see L is the length, A is the A is the area of cross section of that particular material we are saying. So for a particular material, this length and area will be fixed, right? So it means it can be a constant value. Now this constant can be considered as cell constant. What I am saying? Cell constant. Okay, cell constant. Let us indicate this with symbol G star. Cell constant with G star symbol. So here we have 1 by G rho into G star. Okay, like this. So what I told you, rho means I can write inverse of conductivity, because R means I told you that is reciprocal of conductance. Conductance is equals to reciprocal of resistance we call. Similarly, conductivity will becomes reciprocal of resistivity. So I am writing here 1 by K into G star, which is equals to 1 by G. So from this we are getting one important equation, K equals to G into G star. So once again, so what is K, what is G, what is G star here? So K means conductivity, G means conductance, G star means cell constant. Okay, so these are the three things. Now since I already given you the units for all of these, I want you to give the units for K, G star, already G star is given, K, I wanted to get units for K and this G. Okay, so what is the units for G here? 1 by rho, 1 by R we have. 1 by R means what? So inverse of resistance or reciprocal of resistance. So reciprocal of resistance means, so reciprocal of ohm, so that will be ohm inverse, that's it. What is the units for conductance? It is ohm inverse, or you can simply say mho. So you can say ohm inverse is the units for G, or you can also call it as ohm inverse, or you can say mho, like this. Okay. Now I just wanted to ask you one question in the comment box. So what is the units for this conductivity? What is the units for this K? So this is my question for this lecture. So I wanted to get the answer from you for this K. What is the units for K? Write in the comment box. Then next, so we discussed about conductivity or the specific conductance, that is what K, and what is the relation between them also we discussed. Now let us see one question also based on this. Now first of all tell me, which of the following solution of NaCl will have highest specific conductance? So tell me highest specific conductance. So specific conductance means K. Okay, normal conductance means just conductance means G. Okay, whereas G star means this is cell constant. So G will be more. Okay, so G will be more conductance we can say. If G is more means conductance we can say. K means, so it is a specific conductance. It means conducting power of all the ions present in 1 unit volume. So now in 1 unit volume, when we will be seeing more number of ions, so if it is having more amount of concentration, we can see more amount of concentration, more will be the ions, so more is its conductivity, right? So K means what? The conducting power of all the ions present per unit volume, So in per unit volume if I want to consider, so where do we have per unit, in per unit volume more number of ions? See, more is the concentration, more will be the number of ions in that per unit volume, so more is its conductance. So where do we have more concentration here? In option number 4 we have more concentration, so that will be having more specific conductance. Hope it is clear, or more specific conductance, you can say simply conductivity. So fourth option is the correct answer for this question. Next, So we need to study little more about this molar conductance, then we will be seeing some questions. Okay, look here, the molar conductance which is indicated with symbol del. Since we are saying molar, indicate M here. So that indicates what? Molar conductance. So it is defined as conductance of all the ions produced by ionization of 1 molar solution of an electrolyte. Okay, so whenever you have the ions like electrolytic solution of 1 liter, let us say, or 1 molar solution, let us say. So 1 molar means what? Number of moles of solute, that should be 1 present in 1 liter, like that it should be. Okay, so now the conducting power of all the ions produced from that particular electrolyte can be considered as molar conductance. Now this molar conductance will be, now what? It will be directly proportional to what? Its conductivity, right? So K, so we are taking per mole na, molar na, so here C represents what? Molarity. So we are expressing this per centimeter cube or per ml, so you can multiply with 1000. So this is the relation you have to use here. So what is this K indicates here? That indicates conductivity, M indicates molarity. Okay, so what is the units for this del M, they will be asking you. So what is the units? So here S indicates, that is inverse of resistance. Okay, ohm inverse also they indicate, or S they will be indicating here. Okay, into, so M square, so that is meter square in the SI units, or in CGS it will be centimeter square. Okay, so mole inverse in the both cases. Okay, this is a formula you should remember. Okay, so this will be used when we are expressing our answer in terms of this ohm inverse centimeter square into mole inverse. Okay, so now here we have a question. The conductivity of 0.25 molar solution of KCl at 300 Kelvin is this much. Okay, calculate its molar conductivity. So calculate its molar conductivity. So molar conductivity symbol is what? Del M. Okay, so its conductivity is given. So conductivity is indicated with symbol K, right? So K and its concentration, see, conductivity is given this much and its concentration is this much. Okay, K into 1000 by molarity, that is what? Concentration. So K is how much they given? So it is 0.0275 into 1000 by molarity is 0.25. So how much you will be getting here? So it will be 2.75 into 1000 by 25 if you want to write. So what we can say, 275 into 10 by 25. So this will be giving us 110, right? Yes. So this is a value. So 110. So what is the units here we can say? Ohm inverse, next is centimeter square and mole inverse, like this. Okay, this is your answer. See, based on this, so I have written this. Okay, hope it is clear. So here it is inverse. Okay, so just based on the same explanation, can you answer for this? The electrolytic conductivity of 0.3 molar solution of KCl is given as 3.72 into 10 power minus 2. Calculates its molar conductivity. So how can you solve this question? So just take del M equals to K into 1000 by M. That's it. Just substitute in this, you will get one of the option from here. That's it. Very easy. Okay. Then next. Molten sodium chloride conduct electricity due to presence of what? Why it will conduct electricity? Due to presence of, see, I just told you, molten form of electrolyte or aqueous form of electrolyte will conduct electricity due to presence of free ions like Na plus Cl minus in that solution. Okay, it is because of free ions, whereas metals will conduct electricity due to presence of mobile electrons, right? So these are two terms you have to remember. Next, the conductance of 0.01 normal acetic acid solution is given this much, okay, which present in a tube of length 6 centimeter and cross sectional area this much. Okay, the molar conductivity So molar conductivity formula, what we have, molar conductivity we need to find. So del m equals to K into 1000 by m we have to use. Now they have given its concentration, that is 10 power minus 2, okay, but they haven't given this K value. So how can we get this K value? Yes, see the other data also they have given. The conductance of this solution is this much, it means G value is given. So how much it is? 4.5 into 10 power minus 4, okay, and having length is given as 6 centimeter and area is given as 36 centimeter square. So from this we can get, G star as L by A. So L by A is how much? 6 centimeter by 36 centimeter square. So you will get 1 by 6 centimeter inverse. This is the value you will get here, okay. So now from this you have G as well as G star. So we need K now. So what is the relation between them? K equals to G into G star. Just now 3 slides back we have seen this relation, right? So using this K you can find, so how much? 4.5, I can write 45 into 10 power minus 5 into 1 by 6, okay. So this will be 2 times, this will be 15 times. So you can write this is 7.5 times into 10 power minus 5. This is the K value, okay. So after getting this, so we got K, now we need to find this del M. So del M equals to what? 7.5 into 10 power minus 5 into 1000 by M. M molarity or normality is how much given here? 10 power minus 2. So 10 power minus 2 means 10 power minus 3. So this will be removed. So that will be having value as 7.5. So 7.5. So we have option number 1 as 7.5. So that is our answer. Hope it is clear, right? Yes. If it is clear, just click on the like button. Okay. Then these are the things that we have to be discussed in this particular session. Now I have given 1 or 2 questions as a work, okay. So you have to answer them in the comment box. I will be looking into it. No issues at all if you have given a wrong answer also, okay. We will correct them in the comment box, okay. So now I will be once again reminding you that, so if you are interested for any of this course which we are going to launch for 11th, 12th as well as droppers, okay. So can feel free to contact us to the mobile number which is scrolling down here, okay. So here this is a long term for NEET, as well as we are providing for 11th class like 2-year program, and 12th class 1-year program will be there for both JEE and NEET. So you can contact to the mobile numbers which are scrolling here for more detailed information. Thank you for watching. Stay connected with us. Thank you.